Hey everyone, welcome back to the Pre-Calculus 20 videos. In this video, we're going to look at Lesson 1 from Chapter 6, which is looking at rational expressions. So in this lesson, we're going to look at simplifying rational expressions. And in order to do that, we're going to use a very similar process to solve rational expressions as we would with just an ordinary fraction. So say, for example, we had 9 over 12. So when we're trying to make that into a reduced and simplified fraction, we want to look for something that's in common with the top and the bottom of that fraction. So if we're looking at, say, 9 over 12, well, you'll notice that both of these numbers can be reduced by a factor of 3. So you can divide the numerator of your fraction by 3 and divide the denominator of the fraction by 3. That would give us 3 over 4. So one thing that's really important here is that that fraction, it might look different, but it actually tells you the exact same thing. So if we were to put both of those fractions to decimal form, we would get the exact same answer. So they might look different, but they mean the same thing. So this is going to be a very similar process for when we're working with rational expressions. So in our cases with this chapter, it won't simply just be a number that we can reduce by. It will be a term that has a variable in it. But same sort of idea, you want to make sure it's in the top and the bottom, and then you could just divide by that common factor. So first what we have to do is we look for any factors that are in common with the numerator and the denominator, so the top and bottom of that fraction. So if rational expression would be in simplest form, or what we say lowest terms, if the numerator and denominator have no common factors. So that's the exact same kind of idea when we were working with fractions here, when we're dealing with just numbers. So 3 and 4, there's nothing in common with those two numbers there. So that means that is the simplest form, or it's in lowest terms. So in order to try this out, we're going to look at one of the examples from our notes. And this is the first example from your simplifying rational expressions section. So in this example, we're going to state the restrictions and then simplify the expression. So here we have 3x minus 6 divided by, or over, 2x squared plus x minus 10. So we first have to look at your restrictions. So we're looking at our restrictions, we're asking, well, what can x be? And one thing here that's really important is that with a fraction, your denominator or bottom of that fraction can never be 0. So in order to list our restrictions, we want to find out what values for x would make that denominator 0. And then we'll just say that our restrictions cannot be those values. It could be anything else because it doesn't matter if it's positive, negative, a decimal, it just can't be 0. So your first step here is to set your denominator equal to 0. So you have 2x squared plus x minus 10 is equal to 0. Now, right now, it's still pretty hard. You can't really tell what value for x would make that 0. So what we should do is we should simplify that. So in order to simplify that, we can use factoring, or in this case, it'd be called decomposition. And that's using that product sum method. So we're looking at the product. We're looking for the multiplication of the first and last term. So we're going to go 2 times negative 10 is negative 20. And then the sum is this middle value, which is that b value. So if it's just plus x, we're assuming that's a positive 1. So from there, you want to think about two numbers that multiply to negative 20 and have a sum of positive 1. And if you guys ever get stuck, just remember you guys can always make a list of factors of numbers that multiply to negative 20. So I always start off with just writing out the positive numbers. I'll write this up top here so it's out of the way. But you can go 1 times 20, 2 times 10, 4 times 5, and that should be everything. So then you would ask, well, if this is a negative product, that means one number has to be negative, one has to be positive. And you have a positive sum, which means that the bigger number has to be positive. So let's make all these smaller numbers negative. And then just ask yourself, well, if you add these two together, which one gives you a positive 1? Negative 1 and 20 gives you 19. negative 2 and 10 is 8, negative 4 and 5 is positive 1. So these are your two numbers here. So therefore, we're going to use negative 4 and positive 5. And so what we do with those two numbers is we're going to rewrite this middle term here using these two coefficients. So we have 2x squared, and we're going to go negative 4x. So remember, this middle term here has an x. And then this is positive 5, so separate with that plus sign. So plus 5x, and then minus 10. So you're literally just going to rewrite this middle value. So from there, what we want to do is we want to group together the first two terms. We want to group together the last two terms. And what we want to do from there is pull out a common factor from each bracket. And if we do this properly, we should get the exact same values within those brackets. It should look exactly the same. So looking at 2x squared and negative 4x, there is a 2x in common there. So you're going to pull out a 2x, and you're going to write down what you're left with. In order to do that, you just take your original term and divide it by 2x. So 2 divided by 2 is 1. X squared divided by x is just x. Then we have negative 4x. So negative 4 divided by 2 is negative 2. And then x divided by x is just 1, or we won't write that. Then looking at our second group, we have 5x minus 10. So what's in common with these two here is we have a positive 5 in common. So we're going to pull out a positive 5, so separate that with a plus sign. And you're left with x minus 2. So if you notice here, these two brackets here are exactly the same. You have x minus 2 and x minus 2. And that's exactly what we want, because now we have two terms, and we're going to pull out the common factor of x minus 2 from each of those brackets. So if we pull out x minus 2, we're basically left with what's on the outside here. So we're left with 2x, and we're left with positive 5 or plus 5. So that's equal to 0. So from here, what you're going to do is you're going to take each of those factors and set them equal to 0. You've broken them down into the two factors. So you take your first one, which is x minus 2, set it equal to 0. Our equation here is equal to 0, so set it whatever it's equal to. And our second number there is 2x plus 5 is equal to 0. Then we're just going to solve for x on each side. So here we have x minus 2. So to get rid of subtract 2, we're going to add 2 to each side. So we have x is equal to 2. And then in our second factor there, we're going to subtract 5 on each side. So we're left with 2x is equal to negative 5. We want to get x by itself, so this is times 2, so we're going to divide by 2. So we're left with x is equal to negative 5 over 2. We can leave that as a fraction there. So essentially what these two factors here tell us is that when x is equal to 2 or when x is equal to negative 5 over 2, these two values would make that denominator 0. So to finish off your restrictions there, you would say that x cannot be 2 or negative 5 over 2, because both of those values would give us 0 in our denominator. So from there, then we're ready to actually simplify our rational expression. And so to simplify my rational expression, I'm just going to rewrite the expression here. So we had 3x minus 6 over 2x squared plus x minus 10. And so if you guys remember from the beginning of this video, I had said that we need to look for common factors. We're looking at this rational expression right now. There's nothing in common with the numerator or the denominator. But one thing that we can do though is that if we separate these into their simplest terms, like pull out common factors from the numerator, pull out common factors from the denominator, we can see if we can actually maybe simplify some of those expressions. So here we're going to simplify this. So looking at our numerator, we have 3x minus 6. And so you want to ask yourself, is there anything in common with 3x and minus 6? So that there has a common factor of 3. So when you pull that out, you're left with x minus 2. Then looking at your denominator, well, we've already factored this or used decomposition. So let's just scroll back, see what we had for that, and we can rewrite those this expression with those two factors. So here we had x minus 2 times 2x plus 5. These were the two factors when we factored that denominator. So it was x minus 2 and 2x plus 5. So as soon as you break them down to their factors, then you can look at, well, what's in common with the top and the bottom, if there's anything at all. So looking here, we have 3x minus 2. So these are each factors. 3 and x minus 2 are each factors. Then we have x minus 2 and 2x plus 5. So what you'll notice is that you have an x minus 2 in the bottom, and you have one in the top, which means that you can cancel those out. And what you're left with is 3 over 2x plus 5. So there's no other factors in common with your numerator or your denominator. So at this point, you are all done your question. So if you guys have any questions on lesson 6.1, make sure to come see me in class or text me on Remind 101. And thank you guys so much for watching.